My name is Luka. I'm a solution architect at Firebolt. I'm joined here by Jonathan, who is head of marketing at Cube. So, of course, Firebolt, as you might have heard, is quite a new player in this field of cloud data warehouses. We've been here for the last couple of years. But, of course, we respect that it's been a great decade for cloud analytics, right? I mean, if you think about it today, literally you can deploy a cloud data warehouse within a few clicks, right? We take it for granted, but like 5 to 10 years ago, it was really an intensive thing to do, right? Today, you click a few buttons, all of the infrastructure gets provisioned, fully managed, software as a service, it works, right? The other, of course, things that evolved over time, decoupled storage and compute, which allows you to scale storage and compute independently, and of course, serverless, a lot of things along the way. Of course, all of this enable data to flow into your warehouses, and so today, data warehouses aren't really used only for like BI purposes. Instead, we see a lot of use cases kind of growing on top, and we see data apps as one of them. We're going to talk about what data apps are, but first, we do see some of the challenges and why Firebolt is coming here. Today, really, the scale of data is not really single-digit gigabytes. It's going into hundreds of gigabytes. It's going to terabytes. You've heard from Alexandra from AppsFlyer. These data volumes are really huge, right? So in order to perform good, kind of a different view of the problem and a different kind of solution needs to happen. That's one of the challenges. The other is we are really spoiled today by technology, right? So users, especially end customers, external users, really expect like sub-second response from any application, right? So they don't want to wait 5, 10 minutes, or even a few seconds for a data app to respond. To tackle this, teams today do a lot of different things, right? So some of them pre-aggregate data, so therefore they lose the granularity. They lose this kind of raw data view, which is, it's not good. It kind of really cuts off a lot of the insights, right? Imagine you view only like a week or day level or month level view of your data. You cannot really drill down and into the details. That's one thing. The other thing we see is they sometimes analyze smaller time windows, right? Data retention, right? Because the volume is so big, the warehouse cannot handle it. It's like too large or too costly, and therefore, people are just fine with kind of doing 3 months of analysis. In our view, this can be improved, and you'll see why later. To do all of these things, right, there's like a lot of engineering work. Doing roll-up tables, doing aggregations, all of these things are really complex, and they're prone, right? Of course, the other alternative is just accept the slowness or accept the cost, which I think is not the best. So accepting slowness today or slow loads is just, it's unacceptable. We've seen customers coming to us and, Looker dashboards, external-facing analytics, really taking tens or more seconds to load, and this creates problems, right? People not liking the product, leaving, abandoning a sale, or not really enjoying the benefits of what data apps can give you. Imagine like Google Analytics or any of the really heavy data-related products, data apps, being too slow, right? You would kind of you would freak out. You wouldn't like it. So longer than 3 seconds, half of the visitors are gone. So what are data apps? We define data apps as basically kind of packaged analytics solutions. It's kind of an evolution of embedded analytics, but really it's you can view it as a marriage of dashboards and web applications, right? So it comes in many flavors, but one thing that defines it is it needs to be performant. It needs to cater for large data sets, so it needs to be scalable, and it needs to really cater for the end user, provide insights in an instant. One thing that's different is it's delivered by software engineering teams, right? So automation, data quality, CI/CD, all of those things need to be supported, and really, this is the way data apps are delivered. Different types of data apps. It can be full products. I mentioned Google Analytics. You're going to see a couple of examples later on. It can be modules, so different components that just provide, let's say, some data visualization on top of an existing app. Or it can be internal tooling, like your traditional Looker or BI tooling. A couple of examples from some of our users. A product, of course, like a full data app. If we go further, we see a module. This is coming from SimilarWeb, I believe. So a module to analyze things, really working on raw data, giving like sub-second response. And lastly, internal tooling. This is a case from AppsFlyer, for example, Looker. So what are the things that really make up data apps? What are the important elements of data applications? Definitely, as I said, it's performance. Sub-second is what we see, like low latency. This is where Firebolt shines. The other is flexible use of a model, right? So the data model still needs to be defined well, right? We don't do real magic here. It's the data model needs to happen. It's coming to one of the discussions and questions that were asked previously. So, but what we see is when you have like raw data, when you can really create a dimensional model and you can make it work, then it's fantastic, right? Then it works on top of big data, then it's scalable, and we see Firebolt adding value here. So, what is Firebolt? I mean, you've heard about it for a couple of iterations right now. It's a fully managed cloud data warehouse, so software as a service. And really kind of three tenets or three pillars where we focus on is we are built for developers and engineers. So really focusing on giving you the ability to create all of these indexes, right? To tune the engine to work. And also giving you a lot of kind of REST API access, SQL access, all of the tooling, all of the SDKs on top of it to plug this into your architecture. The other is performance and scale. You've seen in these cases really like terabyte scale, but we do have customers who are starting at gigabytes. They anticipate rapid growth, right? So they start gigabytes. We cater for those kind of use cases, but also multiple terabytes. We have a customer who's running a table of a couple of trillion rows, so quite large. And finally, it's a modern cloud-native architecture. So there's a slide later on where we actually show the composition of Firebolt. It's decoupled storage and compute running on top of AWS today. So we've heard speed and performance throughout the slides, right, throughout the talks earlier. The primary element or the kind of the main ingredient to all of this is what we call a sparse or primary index. Each table in Firebolt defines a primary index, and this is the way we sort, compress, and index the data once it's being ingested and stored within Firebolt. You've heard Alexandra mention F3 format, triple F. That's an internal format in which Firebolt stores data under the hood. You don't actually see F3. You don't get to interact with that directly, but as you ingest your Parquet or JSON or any other type of format, during the ingestion process, we index, sort, and compress the data into F3 and store it under the hood. So the sparse or primary index is based on ranges of rows. So we index data that's much more granular than like partitions, which are larger, right? We index on ranges of rows, and this allows us to find data more efficiently. And of course, by finding data more efficiently, we use less resources and incur less cost. The other two types of indexes, this is the way we define it. I can also show it in the demo soon. The other two types of indexes, as we heard, is an aggregating index, which is a sort of our take on the materialized view. The aggregating index is really useful when you have large data sets on top of which you do aggregations or you need to calculate measures on the fly. So imagine having like raw payments or raw data in AppsFlyer case, like raw events, and you want to do something like calculations of distinct users or summing up a total value of payments across time, those sorts of things, right? So whenever you have something like a group by statement in which you do any of the aggregations and you need to be very snappy and support concurrency because you need the resources to support concurrency, you need to be really fast and efficient in how you process this, you would use an aggregating index. The way you define it, pretty simple. You list the columns in your table, which are part of kind of dimensional data, right? And then you list the measures or the aggregations. In this case, it's a sum, average, count distinct, whatever SQL statement you want. Once this is defined, Firebolt will manage it for you. So whenever you have new data or increments flowing into your base table, the ag index will be updated. So no need to, basically, you create it once and that's it. In terms of cost, remember there was a question on cost. The only cost here is the engine uptime. So if you have an egg index running, there's no additional cost of that, right? We charge by the engine uptime. It's up to you how you use that time. So that's one thing. The other type of index, which is really interesting here, so aggregating index solves the raw data problem, right? You now have the ability to store raw data and process on the fly, basically get aggregates on the fly. The other is join index. Join index really helps with dimensional modeling, right? If you have a star schema, you don't need to denormalize. You can really have a fact table with dimensional tables across, and you can use a join index to accelerate joins, right? Joins are pretty expensive operations. With a join index, what happens is this is basically a hash table. It's being kept in memory of the engine. And so it's a lookup, right? So if you do a join between two tables on game code, and you need these two dimensions, it's basically a lookup from RAM, directly from memory, which is, of course, very, very fast. Just one more thing, and then I'd like to do like a very short demo, because we were discussing a couple of things that I want to show ad hoc before I give word to Jonathan. So architecture, like very high-level view of Firebolt. You can see 3 layers here. At the bottom, AWS S3, we use that for storage. So the data that's coming into Firebolt is being transformed into F3 format, which is basically the indexing and the data, right? Which is sorted, compressed, and indexed. We store this on S3. On top of this, you have Firebolt engines, which are compute power, right? So you can have one or more of engines running. There's an ingestion engine here in this picture and an analytics engine. So basically an ingest engine, which is writing data, and the analytics engine that's reading it. There's a variety of options for each of these engines. I'm going to show you in a demo. It's pretty granular what you can choose from. There's engines for specific workloads. And then on top, you have your usage of Firebolt, right? Your services. We have some built-in services like our UI, administration, metadata, all those sorts of things. And then like really a number of SDKs, JDBC drivers, REST APIs, whatever is on top is basically using Firebolt and interacting with it through SQL. So a quick demo of the product. All right. Cool. I hope you can see the screen. All right, so this is the Firebolt UI. This is our main web-based application for which you interact with Firebolt. And if I do a show tables, this is a demo database. It's actually coming from AppsFlyer, a demo data set which they gave us. And you can see the tables we have in this demo database. The main table, lifetime value, 1.8 terabytes of compressed size. And then uncompressed 31 terabytes before it was ingested into Firebolt. So quite a large table. Let's see the count from this table. Oops, sorry. Let's do this. So 57 billion rows, right? Quite large. Now let's see a typical query that's coming to Firebolt from Looker, for example. In this query, and I'm going to execute it quite quickly, several things are happening, right? So we have our fact table here, LTV, 57 billion rows, right? We join this fact table with 2 dimension tables. We get some data out of it. We do some calculations here, and then we do some filtering, right? So kind of a typical SQL query. This one is actually quite simple, but it proves a point. So you can see that when I execute this query, out of the 2 terabytes of data, we only scan less than 4 gigs, right? Because of the primary index that was defined in this table, we're able to find data quite efficiently, right? So we know where the data is, so we don't waste resources, CPU, clock time, everything. We are very fast in finding data. If I extend this, you see that this is like 2 weeks of data. If I extend this to a month, let's say, you're going to see this, how it scales, right? So still we are below a second, right? 0.5 seconds for this. Again, extending this to like 2 months, you're going to see how this works. So quite fast. So primary indexes is one accelerator here. The other accelerator for this query, if I do an explain, just to see how it looks. So if I do this, you're going to see that actually this query uses an aggregating index. So the source for the query is an aggregating index table, so a materialized view that was defined. And basically, Firebolt pre-computed a lot of things during ingestion. So whenever data is flowing in, we are updating this index. And if the query optimizer sees that your SQL query has the columns in the group by and the measures in your projection list that match the aggregating index, it will return data from the index, right? So if I show you the DDL for this index, it's going to be quite obvious. So we're going to go here. And at the very bottom, there's the definition of our index, right? So you see that our aggregating index is defined on the LTV table. It has those columns which we're grouping by, and then it has the calculations. You'll notice that some of these aren't being used, like the count distinct, but still the optimizer is smart enough because this level of granulation is what we actually need to serve data for that query. It's going to serve data from here, which is pre-calculated. No need to waste resources. Data is already there. So yeah. Any questions? Okay, I'm done with my part. Awesome. So handing over to Jonathan, who's going to guide you through what Cube is and how it plays together with Firebolt to create data applications. Yeah.
There's more point than me as well.
You can also do aggregations on top of the aggregating index as well. So if you get into a subset of the grouping clause, Firebolt will use that aggregating index and do further aggregations on top of it. So back into the question around cost and number of aggregating indexes, you can cover queries with one aggregating index, if that makes sense. So you don't have to create an ag index per query.
You showed that the initial kind of data set that was like a very, very big, like 30 gigabytes.
Yeah.
And then you put like a query that has a couple filters per like data range plus an extra filter there.
Yeah.
This is license taking how many of that 30 terabytes of data that's in that table?
So the scan was around 4 gigs.
Okay.
Out of the, yeah.
So like by applying that filters, you are only
Yes.
selecting like a smaller number.
Sure. Yeah.
One back here.
I'm a data scientist. I want to understand how hard is it to learn indexing via Firebolt? Is it similar to usual indexing via any other software like Oracle?
Yeah, so to repeat the question, it's around indexing and how to learn it, right? How complex is it? It's literally those 3 statements that I've shown. So one is a create table statement with a primary index clause, where you basically list your columns that are part of the index. The other 2 statements are a create aggregating index and a create join index. Really that simple. Okay. We have samples in the docs page. It's, I would say, quite straightforward. It's something where, to the question before, it's mostly around identifying the kind of usage patterns of your queries and then hitting the index on those. Yeah.
Makes sense.
Yeah.
Thank you.
So currently deployed on AWS. What about future plans for GCP, Azure, for example?
Definitely there. I don't have exact roadmap or timelines for this. It's AWS for now. I believe GCP would be next. Yeah.
Yeah, just a question on the performance of the aggregate data. When you're dealing with a multi-gigabyte aggregate index, that's stored to S3, like you said. So on ingestion, you're rewriting that file back to S3 because you're doing an update object. So
yes. Yeah.
What's the kind of frequency of update and ingestion you can do back onto that table that's then generating that?
So the ag index will be updated during your ingestion. So whenever you do an insert from an external table from S3, the index is being updated. It will affect the ingestion performance, so there will be a hit. Depending on the number of aggregating indexes and the kind of granularity of them. Also, there are some more expensive operations, like how distinct is more expensive than a sum, etc. You can expect something like 20% of more time needed for an insert. Yeah.
It seems like you are offloading many of the time requirements to the earlier processes when you put the stuff in the S3 and you do the partitioning there. And isn't this limiting like streaming or any real-time capabilities? Because then that would take, I presume, longer than the 1 second of querying.
Yeah. So currently we are at 30 seconds of latency. There are ongoing efforts to support real-time Kafka. I think I cannot disclose the dates, but it's going to be soon. And it's going to. We've seen some demos. It seems promising. Awesome. Okay.
I am the last thing between you and free beer. We can do this. Hang in there. Hi, by the way. My name is John. I have 2 anecdotes that will be useful. One is that I'm Californian, and the second is that I'm a marketer. These will be relevant. The first, moving on, is by way of introduction, what it is this cube thing is. We are making the world's data accessible and accurate. We do that by consuming data from any data store. Anybody who's got a SQL interface will take it. We organize it into consistent definitions. We'll talk a lot about semantic modeling, relatively speaking. And then we deliver it to any application, and we'll talk about the architecture of our APIs that can serve that data up to whatever it is you intend to consume it with. The inevitable logo slide is here. This may already include you. Magic of slide transitions. There it is. It was originally an open source library, at the time known as Cube.js. We did drop the JS this week. It's now encompassing more than just that original library, and in fact, more of it's in Rust than JavaScript, so we dropped the .js from the library. Let's do another history lesson. The way that BI used to work, the way that we were accustomed to the stack, was ingesting it from the data source, and then everything happened in one application. That would involve defining your access model. That would involve data modeling, and here's where my first anecdote about being Californian is relevant, because in California, we spell modeling different. So on the plane over this morning, I had to change like 13 slides. To the extent that there was caching, you'd configure it for that specific application, and then the application, of course, would have visualization, another word, by the way, spelled differently in California. The challenge to that, however, is that now there are more places to consume the data that you've stored, and the costs have gone down, so you're consuming more of it. Everyone is a data consumer. When I used to work at Mode, we had 2 personas. There was the analyst and the scientist, but now everyone is a data consumer. And then what smart people have characterized as sort of the Cambrian explosion of role-specific data applications. When you combine these sort of features of the new reality, it turns out that it doesn't scale. We're only looking at 2 examples where you have to configure your model, your access control, your caching, and your visualization. And the reality is, actually, according to Gartner, most companies have 4 to 6 discrete tools. And you don't want to, just as a matter of practicality, define things 6 times if you don't have to. At best, you're wasting your time, and more likely you're going to screw up. Duplicated effort is bad. It's just the first principle of computing. Don't repeat yourself. The other thing that really matters is when you don't have consistent definitions. We talked about that a little bit earlier tonight, where we needed to have a semantic layer for basic KPIs, like what is a net sale? It's also the case that many, not Firebolt, but many of those data warehouses were not optimized for high concurrency, and they didn't support the sort of low latency that consumers expect of data. And if you're going to hit them that many times for many of the same queries over and over again, and you're paying for the transit, you're wasting money as well. This is why we talk about being headless. Chop off the visualization layer, separate the analytic application from the presentation layer. Buzzword compliant, we call it headless BI. If you remember the last slide, this is just the opposite of each of those. one definition of each of your data terms. What we used to call a metric store, we can define it more broadly, but call it a semantic layer, define it once. That means that every application across departments, across the company, have the same definition, and to the extent that you're caching things within the headless BI layer, they're getting the same cache results at the same time as well, so they're getting exactly the same values. When you build something to support front-end applications, you generally perform better than if you're querying against a raw data source. And consequently, you're not hitting the data store as often, you're saving a little bit of money. So this is the stack that we talk about for the modern lay of the land. Take a data source, conveniently like the sponsor of tonight's event. In one place, have the data model and access control, which are sort of two definitions of the same concept. Happily split across two televisions, pre-aggregation, which is just materialized query views. That is really important when you're using general purpose data warehouse. It's less important when you've got something as fast as Firebolt, but actually there are still advantages to doing it for reasons of consistency. And then serve it up to the Cambrian explosion of front-end opportunities to present your data in customized way. I think I've been clubbing you over the head with this. Consistency is what comes from having a central source of data truth. If this looks like LookML, it's because we stole the idea. The problem was that if you did a wonderful job defining your model in LookML, you couldn't use it anywhere else, and every company had other tools. So manage it in one place. Consistency is good. There we go. And like LookML, do it in code. Specifically, make a relational graph of measures and dimensions. This enables you to reuse your filters, your joins, your access controls within the code. And we do it in JavaScript. That's sort of close to my heart as a former JavaScript guy. But it's actually got some specific benefits if you're trying to do end user facing applications when you can do mutations of that code at runtime. It's also just the fact that you can't clean up YAML that well. JavaScript is a lot easier to clean up. And then specific to how we do it, we've got a lot of Rust-based processing on the side, which is based on Fusion. I warned you the second piece of anecdata was that I was a marketer. Marketers love QR codes. I have no idea if that's going to work split across 4 TVs. But the reason that it's there is I encourage you, rather than showing a lot of CI on the screen, I want you to go and check out. We do a fairly deep dive into how our data modeling works, and it's in fact open sourced, so you can get under the hood and figure it all out. Did not work. At least it didn't glitch and send you somewhere else. We talked a little bit about access control, but that's basically when you're defining your data model, if it's in a single place and you can do row-level access controls, it's a lot easier to build embedded analytics features with security built in at that layer in the stack. And then, I mentioned I was a marketer, we have to have GIFs. So this is animated too fast to read. But the last piece that faces your application, Cube has REST, GraphQL, and SQL APIs. SQL being consumed by a lot of the legacy tools. If they've already got a Tableau installation or they've already paid for Power BI, you just point them at us instead of directly at your data store. If you're building something fancy, GraphQL, because GraphQL. And the rest is used quite a lot of embedded analytics, sort of custom mobile, in particular mobile features. Here's where we're going to be doing a demo, except 2 things are conspiring against us. 1, I don't have a laptop, and 2, we're doing the internet off of a hotspot. So I'll show you a screenshot in the QR code, and I'll tell you what it is that you're going to play with your free beer right after this talk. We took logs from Wikipedia, about 4 terabytes worth, And we ran in real time analysis of outliers, which is to say a particular piece of content on Wikipedia that for one day had an outsized amount of traffic relative to every other day averaged over a year. Computationally, you can imagine what that entails. The fact that it's really high cardinality is what makes this really interesting and fun to play with. As I already mentioned, we're doing it with Firebolt because Firebolt turns out to be best for processing that kind of data size. Oh yeah, another one, analyze, misspelled in California. Then use Cube for all those 4 layers that I described before, the headless BI piece. We baked a sort of a sample application with React and Nevo, which was actually kind of fun to play with. And as you can imagine, because it was end user facing, it actually had to be performant. If you want to follow along, don't try to take a picture of that, but you can find me later and I'll give you the link. And we will not do it live. But I will be here all night to take questions and hand out swag. And thank you so much for sticking it out.
Any plans of integration with DBT at some point? Instead of just your...
So, bear hug your frenemies. DBT has been talking about a semantic layer of their own for almost a year at this point. They keep kicking the can down the road. In the meantime, some of our customers just needed to actually make something that works. We happily announced a way to use DBT for the sort of upstack of us. They unsurprisingly didn't want to retweet it, but we actually do have a step-by-step tutorial for making that integration work.
I have been into few sessions for Databricks. You probably know them very well. So now we have 3 companies on a platform, Cube and Firebolt and all. I want to highlight one point over here that there is one very important point which new companies should follow, that as much tutorials they release and as much hands-on they allow to new people and developers, the more I was talking to the guy recently. So the more they will be into market and developers will learn more and eventually companies will have ready resources. So what is the plan about that?
I think that companies generally specialize. Databricks actually really loves us because generally people build on top of that data and they're unlikely to rip out their stack. If somebody wanted to build a semantic model into their warehousing product, again, well, DBT was going to build into the transform product. They haven't done that either. We generally believe that we're the right tool for the job.
Training.
Specifically how to help get more people on board.
You are training new developers, those are trying to get hands-on on your tool. What are your plans? How you want to capture the market piece?
So, a wild story, when I was at Mode, this was true, it might still be true, the single best website content to get people into Mode, into the product, was their SQL school. It was literally how to do anything in SQL. And then there was thought leadership blogging on top of it about how to be a data scientist. And there was sort of the aspirational reach where if you're still learning SQL, you might not be a data scientist yet, but support what people actually need. So I'd say content marketing, I warned you I was a marketer, should support the entry-level use cases. I think in our case, it probably means more literacy with SQL. And then on the other side, it means sort of more vertical specific integrations with tools like Firebolt.
Perfect. Do you still have an open source version?
Absolutely. And all we did this week was change its name. And in fact, on GitHub, because you can't easily rename your repos, it's still called Cube.js. There's more to Cube's paid product than just hosting, but it turns out that managed infrastructure solves a lot of problems for people. If you like fighting with Docker, you should feel free.